The power rule. The power rule is actually a special case of the chain rule. And what we're looking at is the derivative of some function to a power n, where n can be any real number. And of course what you'd like this to be, of course, is n times the function to the n minus 1 power, which is the way it is when you have x to the n. But then you have to also include times the derivative of f of x. A nice example of this is the derivative of 4x to the 5th minus 7x squared to the 103rd power. Now, of course, you wouldn't want to multiply this thing out. It would take you quite a long time. But it's very simple with the power rule. You simply bring the 103 out front, subtract 1 from the 103 in the power, and get 102 times the derivative of what was inside here, the 4x to the 5th minus 7x squared. And, oops, I'll get this thing to work here. I'm having trouble with my computer. Here we go. And when you do that, you get this. Of course, the derivative of this is just 520x to the 4th minus 14x. And then we can rearrange this a little bit better like this. And it looks a little better. And you don't have to multiply this thing through. This is fine. This is a good form. Now, we have this special case because this kind of a derivative comes up a lot. Another special case of the power rule even is the derivative of a function of x, a square root of a function of x, excuse me. And this comes up a lot too. And so there's a nice little rule that can be derived, and that's what we're going to do. So when we take what happens when we take the derivative of the square root of a function of x? This is really the function of x to the 1/2 power, isn't it? Here it is. And what we do is we bring the 1/2 out front, we lower the power by 1, and then we multiply it times f prime. And then I've simplified it a little bit here. F prime of x over 2 times the square root of x, because the negative 1/2 power brings it downstairs, and you can change it back into the square root of x. So here's the nice rule that I was talking about. The derivative of the square root of f is just f prime over 2 times the square root of f. And this allows you to do a lot of very complicated derivatives in your head, practically mentally. For instance, we look at this one, this example, the derivative of the square root of x cubed minus the sine x. Well, you know you're going to put this whole thing down in the bottom, and then the denominator, multiply it by 2, and then you want the derivative of this on top, and you can almost do this in your head. But here it is written out. We get 2 times the original function here, down here in the bottom, and then we have to take the derivative of this, which merely comes to 3x squared minus cosine x.